Hi future doctors, welcome to the next class. In this class we will see Stokes law and terminal velocity we will see. So what is Stokes law? So what he said about which force he has given the information for which objects. So according to Stokes law, viscous force is always directly proportional to coefficient of viscosity and directly proportional to radius of the spherical body and directly proportional to velocity of the spherical body whenever it is moving in a fluid. Fluid means that may be liquid or gas. If you remove this proportionality, they will write one constant, that is only 6 pi neta rv they are going to say. This is the viscous force equation according to Stokes law. When this spherical body is going to be dropped in a fluid, that is nothing but liquid, then how this object is going to be, spherical body is going to be moving within this liquid, and how many forces are going to act. So weight is going to act always downwards, mg. In addition to this, on the spherical body in upward direction, which force is going to act means buoyancy force. Another force is now viscous force. If it is moving downwards, if object is moving downwards, this mg is greater than sum of buoyancy and viscous force. So what is the net force means? Net force is going to be mg minus FB plus FB we will write. This is the net force. But after some amount of time, this weight of the object mg is equal to downward forces equal to upward forces FB plus F. So when downward force is equal to sum of upward forces, net force is going to become 0. Net force is 0 means ma is 0. Mass cannot be 0. Therefore, acceleration is 0. If acceleration is 0, velocity is going to be constant. After some amount of time, when weight of the object is equal to sum of buoyancy and viscous force, then object is moving with constant velocity. This velocity only we will call terminal velocity. Okay, till then velocity may increase according to net force ma equation, but whenever these two forces are going to be equal, it will be moving with terminal velocity. At the time how this equation will be changed, we will see. So mg is equal to, what is buoyancy force equation? dl vg. What is viscous force equation? We wrote 6 pi neta r. So v, this v only we will write vt. So whenever we are writing is equal to here, we have to take here terminal velocity. If you are not taking is equal to, greater than means in place of fv we will take 6 pi neta rv we will take. So is equal to means terminal velocity. Now one by one we will change according to that. So what is small m here? Mass of the spherical body. Mass of the spherical body, they can write it as density of the body is equal to m by v. So mass is equal to dv into, that one we can write here. So db vg is equal to dl vg plus 6 pi neta r vt. So we want terminal velocity. You can write this one left side, 6 pi neta r vt is equal to db vg minus dl vg. So v means volume of the spherical body. So 6 pi neta r vt, 6 pi neta r vt is equal to vg, you can take common, db minus dl. 6 pi neta r vt is equal to, what is the volume of the sphere? 4/3 pi r cube g db minus dl. So 1 r will be cancelled. 1 r will be cancelled, 1 pi will be cancelled. 3 twos, 2 twos. Therefore, terminal velocity is equal to 2 r square g dB minus dl by 3 3s are 9 newton. Now see, if you observe, terminal velocity is directly proportional to r square. Terminal velocity is directly proportional to g. Terminal velocity is directly proportional to dB minus dl. Terminal velocity is inversely proportional to coefficient of viscosity. So, if you are taking this apparatus into the space, in space g value 0, at that time terminal velocity is going to become 0. Next, small r is nothing but radius of this spherical drop. How they will ask questions on this means, if n identical drops, spherical drops during rain season, n identical drops are moving with some terminal velocity 2 meter per second, n identical drops, and these are coalescing to form a bigger drop of radius capital R. Now, what is the terminal velocity of this bigger drop? They will ask if n identical drops are coalescing. So, 8, 27, 64, 125 drops they will give. That is nothing but n identical drops. Then how we will get the formula we will see. So, all of you should remember this formula mainly. Terminal velocity 2 by 9 gr square dV minus dl by net. So, in some books they will write rho minus sigma, sigma minus rho, but whatever they have given, density of body minus density of liquid. Now, we will see the terminal velocity, important equation. Now, what is the radius of this bigger drop? Why? Because terminal velocity of the bigger drop is also directly proportional to r square. Now, how you will get the relation means, volume of the bigger drop should be equal to n times of volume of the smaller drop, according to law of conservation of volume. So, if you combine all these smaller volumes, you will be getting bigger volume. Therefore, n volume of the smaller drop 4/3 pi r cube. Volume of the bigger drop 4/3 pi capital R cube. So, these two will be cancelled. Then r cube equal to n r cube. Then r is equal to n power 1 by 3 r. Very, very important equation. In competitive, you will get so many times this equation in surface tension, in potential, you will get so many times. Capital R is equal to n power 1 by 3 r. So, this is the radius of the bigger drop. Now, terminal velocity of the bigger drop. Terminal velocity of the bigger drop is directly proportional to r square. Now, what is r we got here? N power 1 by 3 small r whole square. Isn't it? Square is there, n power 1 by 3 small r. Therefore, terminal velocity of the bigger drop is equal to n power 2 by 3 r square, or directly proportional also you can write. So, in place of this r square, what we can write? Terminal velocity of the smaller drop. Therefore, terminal velocity of the bigger drop is equal to n power 2 by 3 terminal velocity of smaller drop. So, constants will be cancelled, directly proportional. Therefore, this is the relation between terminal velocity of the bigger and smaller drop. You should get n power 2 by 3. Now, see the question, each terminal velocity of the smaller drop is 2 meter per second. This is 2 meter per second. 8 drops coalesce, let us assume. 8 drops coalesce means, combining means, terminal velocity of the bigger drop 2 cube whole power 2 by 3. So, terminal velocity smaller drop is 2. So, 3 3 will be cancelled. 2 square 4 into 2. So, 8 meter per second. So, your practice should be, here they taught with 8 drops. You have to take 64, you have to take 27, you have to take 125. So, 27 means what you will get here? 3 cube. Then 3 square into 2. So, 9 into 2, like that you will be getting. So, 64. So, 4 cube. So, 4 cube, cube will be cancelled, 4 square into 2. So, 125, 5 cube. So, 5 square into 2. That is your practice, not same problem, isn't it? This is the very important equation for terminal velocity. How they will ask question means, raindrops which are in spherical, 8 drops coalesce to form a bigger drop. But where raindrop is falling means, it is falling in the fluid, that is nothing but gas. Gas is also fluid. So we will think spherical drop should fall within the liquid, not like that. So this is also is moving in the fluid. So therefore, you have to apply carefully. So totally you got, according to viscous force, you got two equations. One is neta A dV by dx. Another one is Stokes law. Fv is equal to 6 pi neta Rv. But this formula will be applicable for only spherical bodies which is having radius. Stokes gave for that object only. So this one is area, velocity gradient, coefficient of viscosity. They will give two plates which is having area, velocity gradient, velocity is changing with respect to distance. They will give what is the viscous force or coefficient of viscosity. They are going to ask. At the time you have to use this formula. So today, so we have done this terminal velocity concept. I hope you people understood. You can practice more number of problems. Definitely you can solve. Thank you.